So, hello, hi everyone, and welcome to the Open Security Summit session in May 2021. And now what we're going to do is we're going to do some threat modeling, or discuss the threat modeling of one of our exciting products called Folder to Folder plugin. Now, it's quite exciting as well because it's the three of us here from the best InfoSec team ever in Glasswall. We're all in the same office. We're all at the same place. So it's going to be like a little panel, a little forum that we're going to discuss and talk about threat modeling. So exciting stuff.
Yeah, we are the best InfoSec team at Glasswall.
Sorry, I mean, did you forget? Did you exclude me?
Ever, that's what I meant.
Well, that's the only one we had. We had also far the Glasswall.
Thank you.
And you are forgetting about me because I'm not in the office. It's not three of you, four of us.
Yeah,
Please.
I was too.
Well,
Never forgotten about us.
You're in our hearts.
Thank you.
Cool. So this product, right? You're gonna go to the next slide, right? So it's a product that we're developing that is designed to process large amount of files. So we actually call our CDR plugin. So CDR is content disarmor reconstruction. It's fundamentally an engine to make files safe, right? We take a file, break it apart, rebuild it into a safe new file based on the spec. So if you go to the next slide, the interesting thing about this plugin, right, and this sort of the workflow we have here is, you probably go to the next one. I can cover this there, right? Is this architecture that can I zoom out?
Yes.
Right? Is this architecture that if you look at the mouse here, so if you look at where I am, it's basically a massive workflow to take files from a source, which we call HD1, hard disk one, then check the hash, make sure that we don't reprocess files again, grab some metadata, which is very valuable, and it goes into the sort of we call HD2. So there's the first step, getting the files all ready, and then there's a kind of a queuing mechanism to send the files into what we looked earlier, which is what we call the Cloud SDK. So this part here is basically the individual cluster. So these are Kubernetes clusters. We have one cluster per EC2 instance that we run that then apply, and they're the ones who actually do the transformation. So one of the things that was interesting, we actually was talking at the end was the load balancing, how it scales, but also who's attacking it, right? And one of the things that is very interesting of this particular project, right, is that when you get the file, you put the file on HD3. So yeah, we go from HD1 to HD2, so HD3. But when you look at this project is also, or this tool is potentially a denial of service generator, right? Like when this project, and it was working effectively, technically this project has the ability to send tens of thousands or hundreds of thousands of requests through a set of clusters.
Yeah.
So it's actually an interesting project that by almost a feature of the application is the ability to generate a huge amount of load. To an API design in a distributed way.
Yeah.
Which comes with its own risks.
Yes, to a lot of the elements, right? But it's interesting that it's not often that you look at an application where the application itself could be a threat to other systems. Yeah. So one of the things that is interesting that one of the workflows that we added here, but I feel that is one of the areas that we have to be better, from a usability point of view, but also from a throttling point of view, is that we have to be careful that this doesn't become a massive engine to cause all sorts of havoc in different places, right? Yeah. And just for reference, all this is open source. Just for the reference, right? Because
I have a feeling someone a hacker in Russia is like now looking up those repos.
Yeah, but look, the bottom line here, like we're not doing anything that you cannot do, with spinning up a whole bunch of Lambda functions and doing that. So if the thing about it is today, like if you want to build a distributed denial of service machine, right? You basically any cloud provider can give you that, right?
Yeah, true.
But I think that it's an interesting element that usually when you do threat models, you worry about your system being overloaded by other systems. This is a system that this system can actually overload others, right? In fact, one of the threats and the mitigation that we have to look here is how does the system actually throttles And one of the worries here of this system is that, and this is another interesting property, is that this the same way that when we look at the cloud SDKs, so when we look at from here, these entities here need to be able to protect themselves from here. Also, this one needs to be able to protect themselves against misbehavior servers. So we've seen this already where we actually have servers that suddenly on bigger loads start to misbehave and actually go into that pattern I was talking before, which is a pattern where the server starts to misbehave and then is not able to by itself come back to a stable state, right? And I think this is, so when you look at the thread model of this, one of the, and then that's where, I go back to the thing I was talking before, right? You can think of this as very simple blocks, right? Where you've got the target here, which is basically the ones that will receive traffic. In this case, there's a load balancer in front, which distributes some of the load, but also this is designed to be hitting the servers directly. And then you've got this whole section here, which is basically what we call the processing section, that you can almost think as one blob. So you can just almost look at the interactions between these two, right, from a pure scalability point of view, right? And then understand every single user flow that you have there. And one of the things that I really like on patterns like this, especially because we control all of this, is that we should then be looking at, for example, hardening the system so that, I would argue that any functionality that exists, for example, here, that is not being used by these guys, right, should not be enabled, right? And that's why, even from a security point of view, the less moving parts, the less attack surface you have, the more solid the solution is. Because it also means that as we look at the deployment of this, and this is why it's so important to think of the whole solution as an entity, is because one of the architectures that we should be implementing, and from a threat modeling point of view, we should be capturing this as risks and as vulnerabilities and as things that, as they get implemented, you get to check the box, right? Because remember that also gives you some momentum. Is I really like us to have a pattern where almost the attack surface on this, it's almost looks like that in purple, right? Where if you look at this design, you almost have this workflow where you just see the source part, which is in red there, right? And you just see the clean files, which is sort of here, right?
Yeah.
And that's it, right? So then you can actually think again from an attack surface point of view, you actually just have almost, guess what, no pun intended, a folder to folder, right? A to B.
Yeah,
right?
True.
And because this is where the worldly maps are so important, right? So in when I look at things like this, in my head, and I still think we need to map this properly, right? Is that there's an evolution here, there's a commoditization, right? And then if you look at the thread models, right? The thread models should represent that, because it means that the more something gets commoditized, i.e. the more it becomes a product very mature, the less number of variables you have, and the more it becomes an item for the next subsystem, right? That then uses it. And then the important thing here is that, every risk and threat that exists underneath will be carried out to the ones above. So you almost want to get a point where whenever we have some of these thresholds, right, we limit to the maximum the inputs and the outputs to those systems, right? So let's say, for example, that there's a slow Lorentz vulnerability here, right? That guy is still impacted, for example, right? That the Nginx in there or whatever we're using there doesn't support slow Lorentz, right?
Yeah.
You can have a situation where this solution doesn't have that vulnerability, right?
Yeah.
Because the input and the outputs happens here and there, right? And what is going to happen is that this is a product that will create the next generation of products. Because, for example, we're already doing integrations from S3 to S3. We're doing integrations from EFS to EFS, or Dropbox integrations, or Google Drive integrations. And they almost start and end here, right? And then there's just the monitoring and the health of the system, But we basically, this is a typical chain of products that we're making black box of the black box of black box, right? But it's important that we lock each of those and we understand the threats of each of the systems, right?
Yeah.
And how everything works.
And that can be used as like a template moving forward, can't it? Because we know the base, if you like.
Yeah.
And going forward, we know because of X, Y, and Z, we can then take into account.
Correct. And this makes a big difference because, for example, like we've done a Dropbox integration, right? The Dropbox integration is actually a pod that synchronizes a folder with Dropbox.
Mm-hmm.
Actually, it makes a lot of sense, right? Because it's
Yeah.
a Dropbox integration. The question is, where does that run?
Yeah.
Right? Because that's going to contain a very important secret, the Dropbox information, right? So,
Correct.
Depending on where that runs, the risk for that becomes bigger or smaller, right? And then when we provide recommendations, the power now of the world we live in is that we have a Terraform script, we have a CloudFormation script. So you should already start to review those scripts and understand the risks that we have with those things. And that's why, again, for the developers on the team here, right, we need to start creating these thread models, these diagrams that you almost abstract at the level, if you look at the world maps, at the level of altitude that we're addressing this, and then knowing that when you're deep down here, if you found a vulnerability that's exposed, that would be propagated all the way up, right? But then you want to make sure a case that what is the inputs and the outputs that goes from one to the other, right?
Yeah.
And this is very important because the other thing that's very interesting is to, and I sometimes think of, it's almost like there's in applications like this, sometimes there's this sort of almost like warp tunnels, warp sort of, what's it called?
Wormholes.
Wormholes. No, exactly. There's some wormholes where if you actually remember that inside here, right, there is a massive, again, set of systems, and inside there'll be a pod, right, that is going to process a file,
Mm-hmm.
right? Guess what? There is a direct line, right? Literally, there's a direct line between here, right? Okay, it's going to be in green. Actually, let me do it in orange, right? There's a direct line between, all of this thing I'm doing right now, right, is almost, from a question is there any validation happening here at all? Now, this is an interesting thread, right? Because you now have an interesting challenge because by design, we want to take the files that are on the source and take it all the way. So basically, we want the file that comes from here and go all the way to the pod that's in there. So you can actually, you can think, well, my pod is nicely isolated in the middle of all this other stuff, where in reality, it's not really isolated because that pod is taking data that comes all the way from the server.
Yeah.
And now an interesting question, for example, is the file name. So the file name, it's an interesting property, right? Because the file name is under the control of the attacker.
Well, yeah.
In which way is the file name in control?
No, the attacker is in control of the file name.
So we specify how they want.
So you can have all sorts
Oh,
of
yes.
payloads in a file name.
Correct.
Right? You
Yeah,
can have
yeah.
character zeros, you can have buffer
That's
overflows
correct,
trigger, you can
yes.
have SQL injections, you can have
inject
patch
code
transversion
by injecting the
vulnerabilities,
file name. Yeah.
right?
Yeah.
So for example, like it's important to understand in this case, how far some of those things travel, right? So it's very important that, and this is why the data mapping of this is so important, right? That's why the data classification of every piece of data is super critical, because you need to look at when I'm in here, what is the things that I control, because this is going to come from, Dropbox, right? So if you then start to picture what's going to happen, you're going to have a whole number of sources, right, that eventually attackers control. And remember that the point of this is to process bad data, right?
Yeah.
So the attackers are going to control the data that ends up here.
However, the attacker then has to control the Dropbox. So he has to drop so it doesn't control directly the data that comes in here. He still has to somehow get that data into Dropbox, right?
Sure, but that's one of the valid scenarios. So for example, one of the scenarios that we have with Dropbox is the customer actually came to us and said, look, I get this data from our partners, and we use Dropbox to collaborate.
Yeah.
So their problem, their security team problem, is that I'm having people outside the company putting stuff into their Dropboxes that is now going to be open from inside the company in our Dropboxes. So how do we make sure that the files that are open in the corporate Dropbox are now safe? So we have to assume that the files dropped in the third-party Dropbox, either the file or the username, are potentially malicious.
Yeah. But then there's still, if an attacker wants to compromise the whole thing, it will still need to compromise the initial sender first.
Yeah, but you have to assume that that's compromised.
Or spoof it.
Yeah, but this system like this, you have to start by the fact that says,
oh yeah, absolutely. But this kind of brings another layer, because it has to be like, it can be accidental, but if it's like on purpose, it's kind of like way more difficult to execute.
What do you mean?
Like, so for example, if I'm an attacker and I want to compromise your Dropbox, and I know that Chris is sending you files, I would have to first somehow convince you that I'm Chris and send you a file into your Dropbox, right?
Yes. But
so that's the first step. That kind of introduces, makes it a little bit more difficult for me, because you won't accept files from me, because who am I?
Yeah, but I think, yes, but on a system like this, we should start by the fact that Chris, or somebody that gave it to him, is malicious.
Oh yeah, absolutely. I totally agree with that. Yeah. But what I'm saying is, if I'm an attacker from that point of view, from the outside, it might be, there's an extra step. But for us, we actually have to assume that, Chris can be compromised even accidentally.
But that's actually where it's important here to map the attacker.
Yeah, exactly.
Right?
Exactly. That's what I'm saying.
Because, for example, like on a system like this, I would argue that with the current design that we have, this should not be able to be attackable directly.
Yeah.
But it could not be, right? For example, like if some of these endpoints end up being public, right? Then it could be that the attacker is hitting this here directly, right? It could be that the attacker found other ways to put files in there.
Yeah, correct.
Right? Mm-hmm. But that would be then a way of exposing the attack surface, right?
Yeah, correct.
And that's, and it becomes very interesting, because, for example, like we on our design, we allow this to be used by, for example, Glasswall desktop. So it could be that this actually is not a shared or dedicated environment. This could actually be a shared cluster, right? So then you can have a situation that, for example, like and this is where it's important to start mapping some of these scenarios, because if that guy here, right, for example, if this system here is now a shared system, and you have a file upload service, and you have an email system, if you have a proxy service, if you have a website feeding these, etc., you might even find that this could blow all the others out of the water, right? Because this thing is designed to hold terabytes, but again, like this can technically bring that down or slow it down dramatically, because again, this system is designed to slow down, right? Not to drop things.
Yeah.
But it could be that one of the features that we need to add to the product, which again, you guys can drive from a security, to say, we need to have some quality of service here, right? So maybe we need to have a case of saying, if a file comes from this client and the client from there, I would always going to reserve some pods for it. So I'm always going to be able to serve that, but I'm only going to allocate 20% or 50% of my pods to, for example, a folder server.
Mm-hmm.
Kind of like machine learning, is it? You're understanding what the users are doing from the end user perspective, and then you're doing an action based on that information.
Correct.
But that could also be like a role of machine learning in here, if we want to. It's kind of like with how they optimize boilers with machine learning, right? Like they look at the patterns, how much energy the boilers use, like during certain seasons, and then they modify the energy consumption based on that. So that could be applied to here, because like using the pattern to see what certain user uses patterns and how much how much computational power it uses. We could use machine learning to optimize that.
And if you're thinking like that, guess who will be invited to the architecture discussions? Guess who will be invited to the code reviews? Guess who will be invited to the regular meetings to talk about the product?
Well, security.
Exactly. See, and that's a key point I'm trying to make here, is that when you start to think like that, you earn a seat at the table, not just for security, but because you're adding a level of thinking, you're adding a level of analysis that comes natural to security, because we think of how can we break this stuff? How can we blow it out of the water? What about the threat cases? How can we protect it? So we have these interesting dual thinking of both attacking and defending that sometimes doesn't come very natural to developer teams or product teams or even other things. So one of my points here is that if security teams can do that, we deserve a seat at the table, not because of security, because remember that eventually our job in security is make ourselves invisible, right? Our job in security is for this to be secure out of the box by default, so that it's almost like the system revolts, or repels insecure configurations, right?
Yeah.
The system starts to fight against insecure stuff because we designed it like that. So security ideally should start to be invisible. The threat models should start to be simple, right? As you go along, because we're removing variables and variables and variables. But it doesn't mean that the security team should not continue to be involved, because if you understand the business, if you understand the use cases, you can then be an ally on both the products and the developer teams, in how they work.
Yeah.
Right? But that's very few security teams achieve that. Most security teams get called in the end going, hey, we need to ship this.
It's happened.
Exactly, right?
Challenge accepted.
Exactly, right? But it's very important that if you look at this, right, to understand, for example, the data paths. Like one of the things that I want to see us do here is understanding all the inputs that happen here, right, at this level, because this is it's almost like this is the moment that is the most dangerous, right? Because this is the place that we know you get malicious data from this system. Now, ironically, here, that is the moment of maximum danger. So the way you want to think about security in multiple layered systems is that each security should be trusting, so it should be protecting itself against the next one. Like this system here, the cloud SDK that we're talking in the morning, should be protecting itself against this one.
Yeah.
So ironically, we actually have built our own, nemesis, over here, because we're building a tool that can technically blow it out of the water. In fact, we already done that, because in the first initial deployments, we were crashing, right, our cloud SDKs left, right, and center, right, because we would send too much traffic to it. So in a way, what you have here is a great testing tool, right, to be able to, basically attack this guy. And what you want to start testing here is what happens. It's almost like this black box, right? So you can see here is that this is what the attacker control. You need to be able to answer how much damage can it be done from here to there. So if you look at now this architecture, it's here, there's some, for example, some not design flaws, but there's some problems that we will have, because from there, that system at the moment is not designed to hold a lot of loads. It's designed to basically, put it right, it's designed to hold the load, but it's not designed to queue it, right?
Yeah.
And then this is where, this is where I have found myself that from a security and engineering, I get to sometimes have this interesting conversation with myself, because I get to think, all right, but if I'm going to build a resilient system, where am I going to put this thing? And my epiphany when I was looking at this architecture, and I realized that the solution for scalability is not here, it is actually here.
Yeah,
right?
makes sense.
Because what's really cool about this, and these are the kind of insights that I think that in security sometimes and I got there from a security angle. This is what I think is interesting. I got, my thinking here was actually security, reliability, and performance. That's how I got to the thinking, right? Because I was looking at, I was simulating attack scenarios, and I was thinking some scalability. And I realized that if you have the same endpoints here, or one of the APIs that we have here, right? Because there's an API there that you have there, you actually have here a way to pace all sorts of stuff.
Mm-hmm.
Think about it. We built an engine to take a huge amount of data, process it, queue it, clean it up, and then send it to the next level down, right? So the best place, for example, to detect abuses is actually in here.
When the data is being analyzed.
Yes.
Yeah.
So for example, like if you drop here, a huge amount of files, right? We might be able to pick up malicious patterns here.
Mm-hmm.
We might be able to protect these guys, right, against abuses over here.
Yeah.
So when you look at this product, you also need to think about where I'm going to put the security features that allow the product to defend itself.
But each of those should be a use case in itself, shouldn't it? And
Yeah.
each of those is a separate threat.
Yeah,
Because it's a
absolutely.
different path through the system.
Absolutely, right? Because what you have here is you have very clear, areas. So you've got, what we call the pre-processing stage, which is to take the files from HD1 and puts them in HD2. So that has a threat model in itself, right? That has a number of properties. That's a number of things that you need to understand. So I want to understand how much stuff can you put on HD1 that you overload HD2. So this is an HD1 where this guy should scale really, really nicely because it's just copying files. Although we found, for example, that depending on the speed of the hard disk, some things can be faster or slower. So there's already some AWS settings that will make a massive difference here, right? And also calculating the hashes and a lot of that stuff, how that works there. But what's interesting about this is that there's no reason why this doesn't happen in half a second, right? If you have a case of you pick up an event from here, this should go quite quick, right? And then there's no reason why that loop there also doesn't happen in seconds.
Would a firewall impact the time to resolve? So if there's a firewall in front of it, would that impact the time it would take to analyze the files?
Well,
slow down the process.
Well, it will slow down, but the question that we need to answer is, what is the impact of that slowdown?
Yeah.
Right. And this is where sometimes we don't make rational decisions in security and development, because if I say, yeah, I'm going to put a firewall here and I'm going to put another security measure here and I'm going to put a data validation there and I'm going to put a data validation here and I'm going to put a load balancer check here and I'm going to put a WAF here, right? And you're going to put stuff there. So I've discussed where people go, well, that's insane. Why do you validate the data across every layer? And I'm going, yeah, because at the moment, like if I only validate the data at the end, I can be blowing up your system, right? Left, right, and center until you get there. Like, for example, if I create a file name that has a megabyte of data, right? Is that a valid use case, right? Because I could create a file name, right, that maybe has an insane amount of data there, but is that a valid use case, right? For, let's say, the scenario that we have here, I can create a 10 gigabyte file, right? Should that propagate the system, right? So there's data validation is a good example. Like, the more data validation you do across the layer, right, the more cleanup you get. And more importantly, the more alerts you have in your monitoring system. So the more early warning signs you get. The question to ask is how long it takes. That's the important question.
Dinis, with a good IPS, like if you have a good IPS system that can detect data integrity changes, and it can validate changes on the fly, as an example. So that's one of the controls you can implement. Yeah. Is that instead of validating the data? I mean, I know validation checks are important, but I mean, like machine learning based IPS, I don't know if you can deploy such a solution, can detect all of that.
Well, yeah, but and I would argue that the more we clean up the data that we give to the machine learning, and the more we can tell those algorithms, this is what good looks like, the easier it is for them to detect the outlier.
Absolutely.
So the irony here is that the more these checks you do in systems like this, the more you detect bugs, right? And more importantly, the more you detect misbehaviors. Because look, we already had cases like this where, this system, right, was being attacked. Right? This system was being attacked by that one, right? Or there was a bug in here that caused a huge amount of traffic to be sent over there. Right, or there was a delay here that it was actually attacked. Because you have to remember that you have this system here has to treat that as malicious.
Yeah.
Right? Not because we develop it that we should say that we don't trust it. So there could be a case where the output here could be malformed. There could be a bug here, or there could be something. And I think that on systems like this, you want to make sure that you start to pick up these weak signals, which are either bugs or some attack going on your system. Sorry, Alex.
No, I just want to say that's why, like, just going back to the point you were talking about earlier which is like, deal with security, like every single system of those, just deal like as a separate entity, like, you know, ESXi021 entity, and do the security there on that system, on that entity level. It will make the security easier and less complex, because if you want to do it on the whole system, it's going to be very, very complex. But if you break it down to small entities, it's going to make it much easier. So I think, yeah, we start from the small entities.
And that's why, you know, I really like this sort of component level. I think that the C4 model, I think we looked a little back in the past, but you want, you know, you want to start seeing these multiple layers, right? Which is again why it scales, because, you know, you ultimately want to start looking at even architecture of code. So you want to start to pick up the patterns, and that's the materials that you want to ask a developer, right? Because you want to say, show me the pattern of this, because, you know, this is a good example of a diagram that it's already a little bit out of date, right? Because we already made some optimizations, we make some changes, right? You know, some of these things here, for example, at the moment, the latest version, you know, we do this in one request instead of two, right?
Yeah.
Because, you know, it was an optimization that we've done because, you know, we push a new feature here that allows us to do that. But you want to make sure that, you know, this is maintained, and you should be checking that. And then when you look at the code, you should be able to follow that in the code. That's why, again, when you do a threat modeling and pen testing, you should always have access to the code, because in a way, this should be priming your brain to look at the codes and then look at what else can you do? Because that's the thing. This represents the happy path, but there could be extra behaviors here, right? There could be extra things that it does, right? That today, you know, it might be an issue. So just go back to the performance, right? If you like your WAF, right? Yes, ideally you want to have a WAF, you want to have security mechanism on every layer. The question then becomes, what's the overhead of that?
Exactly.
Does it depend on the customer as well? Like how much the customer cares about
response times.
Response times.
It does, but first it depends on the application. So if I tell you today that this guy takes between 1 to 5 seconds, right? Or the first version we did this guy took 10 seconds, right? Then something that you add here that takes 10 milliseconds and another 20 milliseconds there and 100 milliseconds there, and it doesn't make a difference.
No.
Right? So for example, we found in the initial test that one of these was enough to handle, you know, 40 or 50 of those, just because of the asymmetry, right? Like that was really interesting data, right? Like we actually found that, you know, just one of these, you know, in a decent machine was more than enough to generate enough traffic, right? To hold that.
Yeah.
But what I think is very important is to be metric driven. So as you know, if you guys put WAFs in here, and we need to put WAFs, and as you put visibility, you know, again, your drive should be monitoring, observability, right? Your drive, you know, you should be able to hold that with facts.
Yeah. And that helps with, if you have a live dashboard in a sense, to be able to see response times and compare it against different scenarios.
And if the team doesn't have that, what do you guys do?
Get dashboards.
But before you do that?
Well, we asked them about it.
Yeah, and if the answer is we don't have them,
Logs.
well, yeah, you open a risk and you open a vulnerability for it, right?
Yeah. On Jira.
Absolutely. But look.
A risk gap 3.
Exactly, right? But I you know, you shouldn't feel guilty for it. In fact, this actually helps development, because those risks are what drives features.
Yeah.
Right? So remember that lack of existence of something is fact, right? If you turn around and says, can you measure this? And if they can't, right, that's a problem.
Yeah.
Right?
Well, it's vulnerability, right?
Absolutely, right? It's a fact that has some security effects, and in my book, a vulnerability is a fact that has security effects, right? So we have a vulnerability that, you know, if you don't understand X, that's a vulnerability.
Yeah.
Now, we might turn around and say, are we happy with it, or we can accept it, or all sorts of stuff, but it's important that that vulnerability and those risks that we do during the threat model, right, are then part of the backlog. So as we develop new features, we understand, well, let's address that too. Right? And this is where you and the developers need to be working very well together, because some of these things the developers themselves should be raising up. But there's an interesting thing that happens, I found, in teams, which is the first 20 and 40 vulnerabilities that hurt the most.
Why is that though?
Because when you add one vulnerability, it feels like a big thing,
Yeah.
right? You almost like you only do it for big stuff.
Yeah.
Right? And it's only when you get to 30 and 40 vulnerabilities that you go down a couple layers. And then it doesn't feel like a big thing, right? Because you're adding more.
It starts to
To
become
it.
more routine,
And-
maybe.
Yeah, but also from a psychology point of view, it means that you understand that you're now capturing side effects,
Yeah.
right? Where if you only have two risks, then you really drill into it. And adding another risk is a big thing, right? Adding another vulnerability is a massive thing because it feels like you only reserve it for the showstoppers.
Yeah.
The problem with that is that a lot of vulnerabilities are a combination of other vulnerabilities or are things that, might look small, but it's only when you drill into it that you really understand the true picture of it. So I view that as weak signals. I view that, you start to talk about the side effects, and it means that you want to start also creating these paths for developers where if I go this way, I get to code and I get to push to production and I get no problems. If I go that way, I'm going to have to open 5 vulnerability tickets, right? And I'm going to open 2 risk tickets. It doesn't mean that you don't do it. It's just you just have that extra thinking of going, okay, can I add some of these things to the feature themselves so I don't
So
I don't
about
do-
doing due diligence, right?
Yeah.
It's kind of,
and ultimately your job in the threat model and the job of the pen test is to find those gaps
and document.
and document them.
And
Yeah.
actually find them early,
Exactly, right?
put them in the design.
So the irony of this is that most systems, especially in a case like this, they're going to have a number of blind spots, right? Or vulnerabilities by design. And if you don't capture them, you're doing yourself a disservice because it means that as the business find new use cases and as the users find new use cases for this, they might be making bad decisions because they might not understand that some of those lines should not be connected because we don't have that stuff. So, let's say a good example. At the moment, this does not have a built-in authentication solution, right? Now, one argument should be it shouldn't have, because in a case like this, we don't need to, because only this one is talking to that one.
Yeah, it's not connected directly to the internet.
Correct. So it's important to understand the limitations. But if you want to plug this dude directly to the internet, right, then you need to understand the vulnerabilities by design on it.
Yeah.
Right. But or you could argue that this guy could be connected directly to the internet. You just understand that there is, a denial of service possibility, or there's a service degradation capability, or we can say we're going to put a WAF in here that protects against a certain number of use cases, so that actually then you can still expose it to a wider set of attackers because you're now protecting against a bunch of
And then you
things.
can say by introducing a WAF, it might impact performance by this amount because of the dashboards we've implemented.
Yeah, but you need to have data to support that, right?
Yeah, exactly. You need the data to be able to see what the impact is.
Absolutely. And the thing about like WAFs and things like this, right, is that if you don't have the data to support it, for me, that's even more worrying because you don't have visibility.
Exactly.
The reason why most people don't put WAFs in front is they don't understand it. They don't understand the side effects. It becomes a black box that then breaks and nobody understands why it breaks. And then the first thing you do is yank it out because, you're introducing variables to the mix that you don't understand.
Yeah.
Right? Where the reality is that introducing a WAF here has the potential to clean up a lot of things. Right?
Yeah,
And that makes a massive difference.
exactly. Providing it's implemented correctly and you understand how it's implemented, I think, and what it's doing. I think that's the main part, is what it's actually doing.
Correct.
Yeah.
So otherwise, like you say, it's going to introduce.
A lot of the things here, right? So one of the things that we need to do in the next version of these threat models is to now really, go down to those individual use cases and those individual patterns, right? And then look at the inputs and the outputs from there, right? So you look at, some of these, for example, like even that's the workflow from HD1 to HD2, etc., right? What are the abuse cases, right? Like, for example, what kind of data flies from one place to the other, right? And I said, like, for example, the username, so the file name is a very interesting one here because the file name is one of the few things that actually the attacker will control that we have to be very careful. So I'll give you an example. There's a reason why when we copy the file from HD1 to HD2, we don't use the file name. If you actually look at the implementation, we actually use source. Right? So we actually have a generic name. So inside of it, you just have a blob of binary data.
And that
right?
dictates what
The
you do.
file name is stored on the JSON file
Right.
as, again, now is just another string.
That makes sense.
But that's, for example, it's a good example of a security capability that we added that needs to be locked in,
Mhm.
right? And this is sometimes what I mean by the threat models should lock the brief, because we should now make sure that even on the code, there's a reference to that, right? So if you look at the source code, and I actually like this idea that even on the source code, we add security references. We make sure that whoever looks at this code base in the 6 months to a year from now, if they start to think about changing that, they need to understand that, look, there's a fact and there's a whole set of threat models that we've done that at the moment are protected, or the mitigating control is the fact that that file name is actually not used here.
Yeah.
Right? Even, for example, the fact that we use the file name, right, needs to be captured individually, because there's a one setting that we need to add here, which is there's an option that I actually think we need to be careful with how far the file name travels, right? Because the file name is also very confidential,
Yeah, correct.
Yeah.
right? Because the file name has a lot of potential, data leakage or metadata that you have to be careful. So we also need to think about this solution is who and which logs and where does the file name exist and in the beginning of the ending.
Logs is an interesting one.
Yeah. Now, the ICAP is an interesting one, because the ICAP, we could drop the file name almost from the start.
Yeah.
And nobody below needs to know the file name, right? And the same thing for the Glasswall API. You can make sure that that's the only one that knows about it. In fact, we can even argue that in this case, the Glasswall API doesn't even know the file name.
Yeah.
So if you actually look at the previous design, how far does it travel, the file name? Right? Because
Yeah.
you can argue that the file name should just stay, for example, on the metadata, right? Because it's needed to, to put it on HD3, right?
Yeah.
But maybe it's not needed to go over there.
So right now, is the file name going the whole way?
No,
And it's stopped. Where does it stop then?
the file name is extracted here, is put on the metadata,
And then the metadata
Right.
carries it along.
and then the metadata, stays on HD2. And the next time it's touched is when we get the new file from here and we write it back here,
Got it.
I see.
right?
Yeah.
But there's patterns here that you guys need to be involved. So for example, like one of the conversations we're having is we copy the file from here to there. So that was the design pattern. So if you look at this pattern, it's taking a file, calculating the hash, and if the file already exists here, the hash already exists, we actually only copied once. So there's actually some interesting optimizations that we've done, but it means that we copy the file from here to here.
Yeah.
And this might sound trivial, but when you need to copy, 10 gigabytes or a terabyte of data, this becomes a bottleneck, right? So for example, at the moment, because this is more of a bottleneck than not, right? We haven't fully optimized this, but I'm telling you, there's a lot of work that we can do here to speed up this process. But again, from a developer point of view, we can process, 5,000 files per minute here, but here, depending on the number of servers, you can only process 500 or 1,000 files, right? Well, I guess, you can always, this technically you can scale up. So if I run 1,000 servers here, yeah, I'll process more. But for example, that was a design decision we made. But again, you guys need to lock that, because, for example, like one pattern that we could have is to not copy the file, just capture the hash of the file, and then get the file from the original disk when we need it. But for example, that now can open some interesting kinds of worms.
Because that would give access to the original file to some services that maybe we don't want them to have access to.
Well, no, because the question is whether the original files lives here or there.
Right.
So these two would always going to have access to the files. The
Yeah.
problem is whether the original file lives only in HD1 or lives in HD1 and HD2. But remember, the HD2 always needs the file because he needs to send it to this guy here.
Right.
Actually, on the other hand, we haven't talked about the encryption. Now, an interesting theory here, which we can look at, is we could encrypt the file here on the way in.
Correct.
Right? So we could calculate the hash, encrypt the file, put the file in encrypted state in HD2.
Yeah.
And this would be really interesting if the only entity that had the decryption key was actually, in here,
So it'll be
Where?
encrypted in transit.
in
like-
there. In
Oh,
the,
I see.
in fact, even better, if the only entity that has a decryption key is the pod that is processing that. Now that would be a really cool security improvements where you can actually have PKI on this, right? Where basically you use the public key in blue, for example, here, right? To encrypt the file. So now the file is encrypted state,
Yeah.
right? And then you use the private key in green here to
Yeah.
decrypt it.
That's an interesting one.
But Dinis, what happens in the pre-processing service? You know what it says SHA-256 hashing
Yeah.
based. So what happens in there?
Well, that calculates the hash,
Okay.
right, of the file. That guy there, right?
Okay.
Yeah. So what we do is we take the original file, we calculate the SHA-256 of the file,
Yeah.
and then we use it, for example, to decide have we seen the file before or not.
Okay.
So when you look at HD2, the structure of HD2 is based on a folder per SHA-256.
Okay.
Which is
Okay.
another interesting actually protection on this, which
Yeah.
is, for example, if you upload, let's say this is again on a receiving end of something, right? If you upload 10,000 times the same file, we will only process the file once.
That's
Which is amazing. This is a good optimization here.
Which is a very good optimization and protection, right? Against this, right?
Yeah.
And I actually think that one of the crazy values that we're going to extract from this is to be able to track where you seen the file and add the metadata. So imagine there's a proxy connected to this. We can start to see where the file got seen, where it got downloaded, and you can start to track, even usage of files based on this, because we can capture and say, and then one thing that we haven't done here, which I think is on the roadmap already, is also to store the rebuild file in HD2. So at the moment, we actually put the file directly in HD3, but and this is where, again, retention period comes into play. We need to think about that. But again, that's a feature that when we work, you guys need to be involved in that, right? In those conversations. And that's why what we really need here is now have these very simple thread models, which is something that we still don't have a good pattern for, where, we just look at the pattern, the inputs and the outputs, almost like the attackers and the defenders on it. And then we map the risks. And then we say, well, this is what's possible in here. And almost, this is the vulnerabilities that we have by design with this system. And this is the ones that we don't have, right? On this. And that's kind of what I want to do. The next phase of this is to review. I want the developer team to start creating these patterns. What you guys need to do, what we need to do for them, right, on the security side of things, is to give them the templates. So you almost start to say, this is what my code is doing. This is a bit. This is the elements of it. And then we almost like, again, we want to commoditize a lot of these mini templates and figure out these design patterns, and then already have a baked-in almost thread model for that pattern.
Yeah.
Right? Like SSL, right? SSL is a good example that we want to have a design pattern here that basically says that if you use SSL, if you use this, if you use that, if you use TLS, then you have no risks. If you don't use that, now we have man in the middle. Now we have all sorts of risks that we need to take into account, how to do that. But again, if you implement SSL, is it a self-signed cert? There's a bunch of stuff that you need to take into account if you do that.
Yeah.
Right?
Yeah.
Interesting.
Cool. Well, I think there you go. We've done our thread models based on the original diagram. And I think the most of the stuff we have here is just the architecture of it, right?
No, we had also some threat modeling stuff at the end.
Okay, let's talk about it. Where is it?
Kind of running out of time. We
Sure.
can talk a little bit.
Yeah, a couple more minutes on it. Oops.
Oh,
Yeah.
so
Yeah, cool.
yeah, so we did so we talked to the devs and we asked them based on OWASP's kind of threat modeling example, we asked them to give us some insight into the application. So Chris could say a little bit about why we did all this. Why did we ask the devs to kind of participate highly on this? Yeah, go for it.
Well, it's only, I guess, the devs are the guys that know it best, right? They've got all the information, they hold all the knowledge. So we wanted to kind of integrate with them to start building out sort of, you know, the architectural diagrams, the data flow diagrams, which would then give us kind of the information we need to then go off and start to threat model it. So in terms of what they actually done, I mean, they provided some very good information on the data flow diagrams. They provided the architectural diagrams, and they also started to create some use cases for us, which again is going to help with the threat model itself. So yeah.
Yeah, and one of the big reasons why we also wanted to, you know, highly involve the devs in it is, you know, we want to shift security to the left, like we were talking before. And when we get them involved and when they start creating these data flow diagrams, they start thinking in a security point of view as well. That way we kind of introduce little patterns in their mindset that, you know, next time they code, they might remember this data flow diagram, and they might remember, oh, you know what, like, you know, maybe with this I'm introducing another level of threats. So by actually getting them highly involved in the threat modeling, we're kind of raising a security awareness in them. And then when they code, they can think about these things preemptively instead of, you know, acting reactively, and, you know, going back to the code and fixing it. Once they've done a couple of threat models with us and they've done a couple of data flow diagrams, they can actually, you know, have that kind of secure coding mindset already. Which also helps with the shifting security to the left, and which also we want to do as like part of a, you know, secure software development lifecycle.
And then overall, that also improves the documentation, right? So you've got solid documentation there that explains deeply how things work, which
Exactly.
can be used moving forward.
And when they do those data flow diagrams, they might remember, oh no, I actually missed this in my documentation. It can go back to it and it can make it more high quality, you know, just by like describing the application well to us, by us asking them those questions, they can actually realize how much, you know, what they could have possibly missed inside the documentation. They can go back to it and, you know, have quite a solid, sound documentation on the whole thing.
I think one thing that's missed here is about threat modeling. So threat modeling is like a pen test on paper. So it is literally, you are mapping out the application and you're doing a pen test, but it's on paper, and then you can use that for the actual pen test, and you can cross reference, I guess.
Yeah, and that kind of helps because the pen testers only have like a couple of days, right, to try and breach your application. So the more information you give them, the better it is, because, you know, a real hacker will have all the time in the world sometimes to do that, while they have only a week. So the more information you give them, the more kind of security architecture and architecture itself you present to them, the more likely they will be to, you know, able to present you the gaps.
And yeah, the more benefit you'll get out of the engagement.
Yeah. So, you know, as part of like, you know, the OWASP model of threat modeling, you know, we ask them to profile their application, to decompose the application, to create a data flow diagram. And then, you know, for us, you know, the InfoSec team, we're going to be identifying the threats, identifying vulnerabilities and risks, and then, you know, seeing which security controls we're going to implement based on a risk assessment. So, you know, Chris, you can say a little bit about the
yeah, so there was different steps we took, sort of different steps we gave, I guess, to the developers to say how is the application deployed, I guess, and what environments is it in. So a series of questions that came back that obviously we deploy in AWS EC2 instances, we've got VMware ESXi, inside a Kubernetes environment. So we asked what type of users the application uses. So in this case, it was regular users and administrators. And then if we skip to the next one, there was a permissions, there we go. So we also asked what permissions those users have. And then that helps us sort of understand, okay, so if I'm a user of these permissions, should I have access to X, Y, and Z? Or if I'm a user, if I'm an admin user, can I retrieve information I shouldn't, essentially? And then the technology used, that's a key one, because if you understand what technology is used, you can then understand the sort of the threats that come with those technologies. The mechanisms. Yeah, so understanding how things communicate, essentially. So HTTP, ports and reports are open. How is the encryption level? So where is the encryption? Sort of, is it at rest? Is it in transit? A bit like what we talked about. This was step 2, right?
Yeah, so step 2 is decomposing the application. You know, we mentioned the WAP, like, you know, will there be a WAF in front of it? Will there be any third parties, external third party services used? And that's pretty much it. Then we got them to do, like, part of the step 2, that's actually the biggest part of step 2, is actually creating those data flows.
Mhm.
You know, showing those nodes between the data flows. You know, thinking about, do we need, where, like Dinis was mentioning earlier, where do we need to validate the data? So, you know, they have done a data flow diagram for us with the Microsoft threat modeling tool, so that, you know, which has thrown quite a lot of threats in, but, you know, conscious of the time, we can take that for the next time.
But I think a key takeaway from this whole thing today is that we should start to take individual use cases and start to threat model individual use cases. So instead of having like a big threat model that covers everything, we should break it down into sections, and then we can really dive down into the nitty gritty.
Which is a graph, right? And then it becomes a map, and then you put that, you know, if you use technology to connect that, you can then create the aggregation of the maps, right?
Exactly.
And the graphs. And that's how you scale it.
And also you can always have like a base threat model, which covers like all the use cases cover, and then you can just say for the use cases, put like the delta and what's the difference between those use cases.
Yep. All right, I think we're good.
Yeah.
Any questions or comments somebody wants to make? If not, we can stop the recording.